Hi, I'm Kim Song-young from the Graduate School of Chemical Engineering, and now I'd like to introduce my research subject, that is the liquid crystal biosensor. We can also call it as the LC-based biosensor. Firstly, let's learn something about the sensing material, that is the liquid crystal. This is the structure of the 5CB. It is a kind of liquid crystal. From the structure, we can find that the 5CB has hydrophobic feature. Then about the liquid crystal, it has orientational behavior and high sensitivity. Liquid crystal is sensitive to the structure of surfaces on the 1 nanometer to 1 micrometer scale. It means that we can use LC sensor to detect the things like chemical compounds, proteins, viruses, and bacteria. I think the most important principle of the LC sensor is the orientational transitions of the 5CB. When the orientation of 5CB transfer from planar to homotropic, there will be some optical response, and this kind of response can be observed under the polarizing microscope with our naked eyes. Then in the picture on the right, we can see that with the different orientation of the 5CB, the images can show different brightness and patterns. Then what I plan to do is using LC to simulate chromatography technique to construct a real-time protein refolding system by designing the device so that the conditions of the whole experiment are similar to those of the chromatographic column, and the protein refolding process will be monitored in the real time. Then let me introduce you something about the column refolding. We can use this immobilized metal affinity chromatography to do the column refolding. Firstly, the his-tagged protein and the denaturant are loaded to the IMAC column with the nickel ions and the NTA inside. Then in this process, the his tag will bind to the nickel ions. Finally, washing the column with refolding buffer, which can remove the denaturant from the bound protein and initiate on column refolding. Then about the LC sensor in my subject, I'd like to use this DGS NTA with nickel ions as an anchoring molecule. It is a kind of phospholipid, also a surfactant. There is an important feature of the surfactants, that is, they are both hydrophobic and hydrophilic. Firstly, I will put the copper grade on the OTS coated slide glasses. Then add 5CB onto the copper grade. Then in the liquid, because of the hydrophobicity of the 5CB, the upper 5CB will be planar, so the image will shine brightly. After adding the DGS NTA with nickel ions on the 5CB, they will be bounded by the hydrophobic interaction. As a result, all the 5CB are homotropic, so the image become very dark. Then come to the protein denaturation process. The his-tagged lysozyme, whether they are native or denatured, they will all bind to the nickel ions on the DGS-NTA nickel ions. But there are differences in the brightness and patterns in the LC sensor's image can certainly be observed. So we can monitor the entire denaturation process with the LC sensor. By the same token, the process of refolding can also be monitored in the real time. And the refolding yield of lysozyme can be measured by image grayscale and enzyme activity. Finally, because a his-tagged protein can bind to a variety of metal ions, I'd like to replace the nickel ions with other metal ions. And then by comparing the refolding yield of different ion experimental groups, I can analyze which ion has affinity with his tag to achieve a kind of balance between the protein capture and the release. That's all of my report. Thank you for your listening.